Hey guys, I wanted to go over this warm up from today since this is part of your studying for benchmark 2, which is going to be on February the 1st. I wanted to just sort of go over it with you and make sure you understood the questions. So the first one says, what is the constant of variation if y varies directly with x and goes through the point 318? So whenever we are varying directly, that's when we have to do y divide x. So all I had to do was y, which is 18, divided by x, which is 3, and 18 divided by 3 is 6. This one is kind of an interesting one, and I do plan on getting some more videos out to you guys talking about this. But whenever we are talking about domain of a function, this is a continuous function, which means it does continue. There should be arrows here, but there aren't, and that's my fault for not double checking that earlier. But domain represents the set of all x values. So when they want to know the domain of the function, they're asking what are all the possible x values that this graph, corresponds with. This is a parabola, which we're going to talk a lot about after the benchmark. But this is always going to be continuing up. And also, as it goes up, it's stretching out further to the left and stretching out further to the right. So this is always going left and it's always going right. So on the x-axis, it's actually eventually going across, well, if I could spell, all real numbers, okay? On the x-axis from negative infinity all the way to positive infinity. So negative infinity to positive infinity because it's always stretching out both left and right as it continues upward. Inverse variation is a curve. Now you can graph it. So you might remember that inverse variation is when k equals y times x. And k is just a constant. So you can make this be some constant. I'll just pick 8 for no reason. I just picked it. And you can see here that that is a curve. You might have also remembered that the formula for inverse variation is y equals k divide x, in which case you could add a slider for k and see that no matter what the value of k is, it's still always a curve. For this one here, what is the x-intercept? So we can actually just copy this and paste it into Desmos. Okay, so here's my graph. And it's asking what is the x-intercept? The x-intercept is wherever this crosses the x-axis. In this case, it's crossing the x-axis at the ordered pair 12, 0. So this has an x-intercept of 12. So slope. Perpendicular is when you have opposite reciprocal slopes. Well, this line has a slope of negative 1/4. If I want to be perpendicular to negative 1/4, I need to be the opposite reciprocal. So the opposite of negative would be positive, and the reciprocal to 1/4 is 4/1, but 4 divided by 1 is just 4. So this has a slope, perpendicular line would have a slope of 4. Next one, find the slope of the line that goes through these points. Now there's different options of things that you could do here. I'm going to show you both ways. So one way is that you could just copy and paste the ordered pairs in here, graph them, look at them, and do rise over run. So you can do rise over run to get from one point to the next. So I can rise up 1, 2, 3, 4, 5, 6 over 3, 1, 2, 3. And 6 divided by 3 is 2. So that has a slope of 2, okay, by using rise over run. The other thing that I could have done is used my, I shouldn't have done that, use my slope formula. So the slope formula is when I subtract the y's in the top, so negative 2 minus 4, subtract the x's in the bottom, negative 2 minus 1, which as you can see, still comes up to a slope of 2. So either way, your slope is 2. All right, this one, a line has a slope of 4 and goes through the point 1, 3. Choose which other points this line could go through. I'm going to explain 2 different ways that you could do this one as well. One way is to just copy and paste all of those ordered pairs into Desmos and look at them on the graph, okay? There's actually one up here too. We can't really see that good. And I've chosen to label the one ordered pair that they gave us in the question. So that's this point here, 1, 3. I'm going to focus on the points up here first. So it says that this has a slope of 4. So a slope of 4 means I need to rise up 4 and run over 1. So if I was going to make 4 a fraction, it'd be 4 over 1. So rise up 4 over 1. So I'm going to do that from the point I've been given and see where I land, okay? So each of these grid marks here represents 1, each of these major grid marks here. So I'm going to rise up 1, 2, 3, 4 over 1. And I land here at 2, 7, okay? So 2, 7 does fit that slope pattern of rising up 4, running over 1. So 2, 7 is on the same line as this if it has a slope of 4. These are only up 1 over 1 or down 1 over 1. So these are not going to be right, okay? Now, I also, I don't know how I did that. I also had this point down here. To get to it, that's going down 1, 2, 3, and over 1, 2, 3. So that's actually -3 over 3, which is -1. That has a slope of -1, so that's incorrect. I also had these 2 points down here. So when I go to check, let me see if I can zoom out better. Okay, here we go. When I go to check these ones, you can start here and go down and to the left, or you can just start at this point and work your way up to here, which is what I'm going to do. So if I start with this green point, which is -1, -3, and I count up and over, I go up, let's see, 1, 2, 3, 4 over 1. I can try it again. 1, 2, 3, 4 over 1. So by using the slope pattern, slope of 4, it didn't get me to that point. So that's incorrect. Let's check this one. So I'm going to go up 1, 2, 3, 4 over 1. And then up 1, 2, 3, 4 over 1. So that one did also end up with a slope of 4, okay? So I'm going to X out these other ones. So I'm going to X out the ones that were wrong and label the ones that were correct. So if you look at them, they do line up, which is a good thing. The other way that you could have done this is used this information to find the equation of the line and then graph that line to make sure which points that it went through. So the actual equation of the line for this is 4x minus 1. So if you look there, that actually does go through all of those points. So that's another way to like check your work there. Okay, so 2, 7 and -1, -5. All right, for this one, now you could solve this by hand, but once again, I'm going to show you a way to do it in Desmos. Obviously, there's a way to solve all of these by hand, but oops, that's not what I meant. But I'm just trying to show you the way to do it in your calculator. Oh man, it's not going to let me copy and paste. I'll have to actually type it. So, and I'm going to use X instead of K. So 3K plus 10, X, I'm sorry. 3X plus 10 equals 2X minus 21. So if you see that, it doesn't look like it's anywhere. I'm going to zoom out. Right there it is. And that's at the order pair -31, 0. So my X there is -31. Okay. All right, how many solutions does this system of equations have? So I'm going to copy this and paste it into Desmos. So remember that In order to have a solution, a system of equations must intersect at some point. Well, here's what my lines look like. And if I zoom out, they're never intersecting with each other because these are parallel lines. This has no solution. Now, guys, honestly, I didn't even have to graph these to recognize that. Both of these lines have a slope of 3, but they have different y-intercepts. So I automatically knew because they had a slope of 3 that these are parallel lines. So they have no solution. All right, is negative 5, 2 a solution to the system of inequalities? So once again, I'm going to copy this, paste it. Oh, it's not going to let me, man. All right, copy it and paste it in there. I wonder if I can do it one at a time. Oh, yeah, okay, good. Just being lazy, I guess. Okay, so here's what it looks like when I graph, and I'm going to zoom out just so we can kind of see a little bit better what's going on. So to be part of the solution to a system of inequalities, you need to be in the double shaded region or touching the double shaded region on a solid line. Now, both of these lines are dotted because of the symbol, which means that if that point is on the line, then it's not going to be part of the solution. So let's type that in here. So negative 5, 2. So let's see, right there's the ordered pair. Now let's zoom in because I want to make sure if it's on the line or over. And this is actually on that dotted line. So that means this is not part of the solution set, okay? In order to be part of the solution set, that ordered pair would have needed to have been anywhere in this double shaded region, this darkest region, or on a solid line. And this is on a dotted line. So we're going to say no, that's not part of the solution set. It's not a solution to this system. And then this is just letting you know you need to be working on your presentation and completing any missing work. But that's it for this warm-up benchmark review. I hope that this video was helpful. Please be studying, okay? Please be studying. Your benchmark is February the 1st. That's Monday, February the 1st. Okay, bye everybody.